Hello everyone, I am your trainer Maurice Monene. In today's session we are going to discuss how to calculate the coordinates of the 2 points of intersection using the two polynomial functions. We know if we were to draw the graphical function, we could have drawn the curve first, and then we could have drawn the line function, and then where they intersect we can be able to get the values of the x-axis. So in this case we are going to solve them using the calculation method, and we know where they intersecting, the value of y is equivalent to the value of y for the two equations. So we can first of all say that the values of y will be the same where they are intersecting. So we can say that here we are going to have 16 x minus x squared minus 13. This one will be equivalent to the other line, which is 2x plus 11. And then from here now we can be able to correct the right terms. We can have this one, we have 16x minus 16x, then minus 2x, then minus x squared, then minus 13 minus 11 is equals to 0. So in this case we can have this one being 14x, then minus x squared, and then minus 24. Because of negative 13 minus 11 is equals to 0. So we can form this one as a quadratic equation, and then we can solve it maybe using the factorization method. And so to solve this one we have negative x squared, then plus 14x, then minus 24 is equals to 0. So here we know that our product is the coefficient of x squared, which is negative 1, multiplied by c, which is negative 24, and this one gives us a positive 24. And then we know that our sum is equivalent here to 14. So we look for two products that we can multiply to get 24 and at the same time add them to get 14, and this one is 2 and 12. So where I have 14x now, I can substitute with this product. So I'll have, in the first case, I'll have negative x squared, then plus 2x, then plus 12x, then minus 24 is equals to 0. So now from here we can factorize by grouping them. So we have this and this grouped together, and then we have this and the other part grouped together. So in this case now, if I factor out negative x outside, I will be left with x, then minus 2, and then if I factor out 12 outside, here I will be left with x minus 2. So I can take the one outside and the one inside the bracket. So I'll have negative x minus 12 plus 12, and then I have x minus 2, and this one should be equal to 0. So from here now I can be able to solve for the values of x. So my first value of x will be equivalent to negative x plus 12 is equals to 0, and this one gives me the value of x being equivalent to positive 12, because if I pass negative 12 on the other side, it becomes a negative 12. Negative divided by a negative becomes a positive. And then the second one is x minus 2 is equals to 0, and this also, if I take 2 on the other side, my x becomes positive 2. So now I can use it to get the value of equation, the value of y using of any of the equation. And in this case I can use the second equation, which is y is equals to 2 x plus 11, and where I have 2 x, I can substitute with 12. 2, I have 2 and then 12 here, then plus 11, and this one gives me equivalent to 35. So the first intersection point of these two polynomial equation will be at position at point 12 and 35, and then the second intersection will be at point, even if you take this first equation and substitute where we have 16 then multiplied by 12, then minus 12 squared, and then minus 13, still it will give you 35. So the second one will be y is equivalent to 2 multiplied by 2 then plus 11, and this one gives me the value of y equivalent to 15. So the second point of intersection will be at 2 and then 15. So these are the 2 points of intersection of these polynomial equation. Later on, we can be told to solve the area that they are enclosed together, and to solve the area they are enclosed together, we can do this. We can say that the area that they are going to be enclosed together, and say that this one we take the functions, that is we have 16x, then minus x squared, then minus 13, and then this the first equation, we subtract the second equation, which is 2x then plus 11 in respect to dx. So in this we can integrate the two equations so that you can be able to solve. Remember, we are going to solve the between 2 and 12, because those are the values of x where they are intersecting. So in this case, we can say that here we are going to have 12 and then 2, and then we can integrate this equation so that here inside we integrate. We know that this one is the same as y is equals to x raised to power n. If we integrate this, we are supposed to have x raised to power n plus 1 divided by n plus 1. So in this case here we are going to have, this one is 2x raised to power 2, and then here we are going to be left with 8x squared, because 2 divided by 16 will remain 8, then minus x cubed divided by 3, and then minus 13x, because x raised to power 0 is the same as 1, so if we add 0 plus 1 you get 13x, and then this one we can say plus c, and then these, remember we are subtracting the equation. If we integrate 2x, this one we get being x squared then plus 11 integrated becomes, because it is 11 x raised to power 0, this one becomes 11x, and then plus c there. So now we can be able to open these, we substitute the two values, and then we can be able to subtract them. So in this case we can have this one being 8, and then here we have 12 squared, then minus the other one is 12 then 3, and here we have this one being raised to power 3, and then this one is minus 13 then multiplied by 12, then this one is plus c, and then these we minus 2 raised to power 2, then plus here we have 11 multiplied by 2, and then here we have plus 2, So, and in this case we can otherwise say that we can say that this one becomes what? This one becomes, if we subtract this and work out this one, we are going to remain here with 1152, then minus 576, and then minus 150. Remember, this here and this will cancel out, and then we can subtract minus 4 plus 22, and this becomes 420, then minus 26, which gives us 394 units. And that brings us to the end of this session. I was your trainer, Maurice Morini. If you have not subscribed to this channel, you can consider subscribing, like and share it so that it can reach more students. Thank you.